Imagine a day unlike any other. The sky blazes with an eerie light, a colossal shadow engulfs the land. A deafening roar splits the air, shaking the very foundations of our world. This is not a scene from a science fiction movie. This is the potential reality of a giant meteor striking Earth. The universe is a vast and mysterious place, filled with celestial objects hurtling through the cosmos at unimaginable speeds. Among them are meteors, remnants of asteroids and comets capable of unleashing unimaginable chaos upon impact with our planet. While the odds of such an event are slim, the consequences are too dire to ignore. Join me as we delve into the science behind meteors, explore past impacts that have shaped our planet, and examine the measures being taken to safeguard our future from these celestial threats. Before we delve into the potential consequences of a meteor impact, let's first understand what these celestial objects actually are. In the simplest terms, a meteor is a space rock that enters the Earth's atmosphere. Often referred to as shooting stars, they create a brilliant streak of light as they burn up due to friction with the air. Meteors originate from larger objects in space, primarily asteroids and comets. Asteroids are rocky remnants from the early solar system, mostly found in the asteroid belt between Mars and Jupiter. Comets, on the other hand, are icy bodies that release gas and dust when they approach the sun. When these space travelers venture too close to Earth and get caught in our planet's gravitational pull, fragments break off. These fragments, ranging in size from tiny dust particles to larger chunks of rock, become meteors. To truly grasp the potential threat of a meteor impact, we need to understand their origins, asteroids and comets. These celestial bodies have fascinated scientists and astronomers for centuries, not only because of their potential danger but also due to the clues they offer about the early solar system. Asteroids, composed primarily of rock and metal, are remnants from the early solar system's formation. These rocky bodies are like time capsules, preserving the conditions and materials from billions of years ago. By studying them, scientists can gain insights into the processes that shaped our solar system. Imagine a cosmic construction site with leftover bricks and rubble. That's essentially what asteroids are. These fragments never coalesced into a planet, leaving them scattered across space. Some are small, just a few meters across, while others can be hundreds of kilometers in diameter. Most reside in the asteroid belt between Mars and Jupiter, but some venture closer to Earth, posing a potential threat. The gravitational influences of planets, especially Jupiter, can nudge these asteroids out of their stable orbits, sending them on a collision course with our planet. Comets, often described as dirty snowballs, are made up of ice, dust, and rock. Unlike asteroids, which are mostly found in the asteroid belt, comets originate from the distant reaches of the solar system, specifically the Kuiper belt and the Oort cloud. As they journey closer to the sun, the ice vaporizes, creating a glowing tail that can stretch for millions of kilometers. This tail is one of the most iconic features of comets, making them a spectacular sight in the night sky. The process of sublimation, where ice turns directly into gas, is responsible for this beautiful phenomenon. While beautiful to observe, comets also pose a risk. Their orbits can be highly elliptical, bringing them close to the sun, and then flinging them out to the far reaches of the solar system. This unpredictable movement makes it challenging to track their paths accurately. Their unpredictable orbits and fragile composition make them difficult to track and predict. Comets can break apart as they approach the sun, releasing a trail of debris that can intersect with Earth's orbit. This debris can lead to meteor showers, which, while often harmless, can sometimes result in larger impacts. Both asteroids and comets can break apart, scattering debris in their wake. This fragmentation can create a swarm of smaller objects, each with the potential to become a meteor. The study of these fragments helps scientists understand the composition and behavior of their parent bodies. These fragments become potential meteors, lurking in the vastness of space, waiting to cross paths with Earth. When they enter our atmosphere, they burn up, creating the bright streaks of light we call shooting stars. However, larger fragments can survive the journey and impact the surface, posing a significant threat to life and property. Section 4. Echoes of the Past, When Earth Met Space. Our planet bears the scars of countless encounters with meteors throughout its long history. These scars, etched into the very surface of our world, tell a story of cosmic interactions that have shaped the Earth in profound ways. From the earliest days of our planet's formation, Meteors have played a crucial role in delivering essential elements and compounds, contributing to the development of the atmosphere and the emergence of life. Craters like the Barringer crater in Arizona stand as stark reminders of the immense power these celestial impacts can unleash. This particular crater, also known as Meteor crater, is one of the best preserved impact sites on Earth. It was formed about 50,000 years ago when a nickel-iron meteorite approximately 50 meters in diameter struck the Arizona desert with a force equivalent to several hundred atomic bombs. The resulting explosion created a crater over a kilometer wide and nearly 200 meters deep. These cosmic collisions have shaped Earth's geology, its atmosphere, and even the course of life itself. The energy released during these impacts can cause significant changes to the environment, including wildfires, tsunamis, and even climate shifts. Over millions of years, these events have influenced the evolution of life on our planet, driving both mass extinctions and the emergence of new species. One of the most significant events in Earth's history, the extinction of the dinosaurs, is widely believed to have been triggered by a massive asteroid impact. This event, known as the Cretaceous-Paleogene extinction event, occurred approximately 66 million years ago. The asteroid, estimated to be about 10 kilometers in diameter, struck the Yucatan Peninsula in what is now Mexico, creating the Chicxulub crater. The impact released an enormous amount of energy, causing widespread fires, tsunamis, and a nuclear winter effect that drastically altered the climate. This catastrophic event, which occurred approximately 66 million years ago, wiped out nearly 3/4 of all plant and animal species on Earth. The aftermath of the impact led to the extinction of the dinosaurs, which had dominated the planet for over 160 million years. This mass extinction event paved the way for the rise of mammals and eventually the emergence of humans. While large-scale impacts are relatively rare, smaller meteors bombard our planet regularly. These smaller meteors, often no larger than a grain of sand, enter Earth's atmosphere at high speeds, creating bright streaks of light as they burn up. These meteor showers, such as the Perseids and the Geminids, are annual events that captivate stargazers around the world. Most burn up harmlessly in the atmosphere, creating dazzling meteor showers that illuminate the night sky. These natural light shows are not only beautiful, but also serve as a reminder of the dynamic and ever-changing nature of our solar system. Each meteor shower is a glimpse into the past, as the meteors are often remnants of ancient comets or asteroids that have crossed Earth's path. However, some, like the Chelyabinsk meteor in 2013, serve as a stark reminder of the potential danger lurking in the cosmos. The Chelyabinsk meteor, which exploded in the atmosphere over Russia, released energy equivalent to about 30 atomic bombs. The shockwave from the explosion caused extensive damage to buildings and injured over 1,000 people. This event highlighted the need for continued monitoring of near-Earth objects and the development of strategies to mitigate potential impacts. Section 5. The Day the Dinosaurs Died, an extinction-level event. Imagine a day 66 million years ago. The Earth is a vastly different place, teeming with life and dominated by the mighty dinosaurs. The air is thick with the sounds of prehistoric creatures, and the landscape is lush and vibrant. Dinosaurs, the undisputed rulers of the planet, roam freely. They have thrived for millions of years, evolving into a diverse array of species that inhabit every corner of the globe. From the towering sauropods to the fearsome theropods, these magnificent creatures are at the pinnacle of their reign. Suddenly, a blinding flash streaks across the sky. It is a sight unlike anything the Earth has ever seen, a harbinger of unimaginable destruction. The flash is followed by a deafening roar, as the atmosphere is torn apart by the incoming asteroid. An asteroid, estimated to be about 6 miles wide, slams into Earth with the force of 1 billion atomic bombs. The impact site, near what is now the Yucatan Peninsula, becomes ground zero for one of the most catastrophic events in the planet's history. The impact triggers earthquakes, tsunamis, and volcanic eruptions that reshape the planet in a matter of hours. The ground shakes violently, causing massive landslides and opening fissures that swallow entire forests. Tsunami waves, hundreds of feet high, crash into coastlines, obliterating everything in their path. Volcanoes, awakened by the shock waves, spew lava and ash into the sky. The immediate aftermath is catastrophic, but the long-term consequences are even more dire. Fires rage across the landscape, consuming vast swaths of vegetation and filling the air with smoke and ash. The once thriving ecosystems are reduced to charred remnants of their former glory. Dust and debris ejected into the atmosphere block out the sun, plunging the Earth into a prolonged period of darkness and cold. This impact winter lasts for months, if not years, drastically altering the climate and making survival increasingly difficult for all forms of life. Plants wither and die, leading to the collapse of food chains. Without sunlight, photosynthesis grinds to a halt and the primary producers of the ecosystem are decimated. Herbivores, deprived of their food sources, starve, and in turn, the carnivores that prey on them also face extinction. The dinosaurs, along with countless other species, are driven to extinction. This mass extinction event wipes out approximately 75% of all species on Earth, marking the end of the Cretaceous period and the beginning of a new era in the planet's history. This event, known as the Chicxulub impact, serves as a chilling reminder of the destructive power of asteroids. The crater left behind is a testament to the sheer force of the collision, a scar on the Earth's surface that endures to this day. While such catastrophic impacts are rare, they highlight the importance of understanding and mitigating the risks posed by near-Earth objects. Scientists around the world are dedicated to studying these celestial bodies, developing technologies and strategies to detect and deflect potential threats. The goal is to ensure that humanity is prepared to prevent a similar extinction-level event in the future.